Ladies and gentlemen, welcome to today's session where we are going to look at different questions under trig. This is one of the throw sheet 6. Okay. So now this one is just for trig. It's all about trig. So as usual, welcome back to the only institute that went to the private school. So now I have answered all the questions here from question 1 all the way to question the last one 23. So if you want to access all the videos, like all the solutions for this tutorial sheet, then go back to our website and then you'll be able to see them. If you look at this website, just type Transcended Institute and then you'll be able to see the solutions. So if you click on math here, go on math. Okay, if you go on math and then we have the throw sheet part, she's saying the throw sheet. We have got both for 1100 and 1120. So 1100 throw sheet for 2025, you just come here, you see that we have got throw sheet 2 to throw sheet 3 to throw sheet 4, 5 which is for throw sheet 1, 5 is for binomial, and also throw sheet 6. Now this is the video, the full solution for that tutorial sheet. Okay, so if you look at this video, it's 3 hours 50 minutes. Now in this video we are going to solve few questions, and then if you want to access all the solutions for this tutorial sheet, just register with us using the link in the description. Okay, so let's start.
Alright, so we'll look at how we can answer these trigonometric questions. So these are coming from tutorial sheet 8. There are quite a number of questions that we're going to handle, different concepts that involve trig. As you can see, these are quite a number of questions. Okay, so this is basically not actually the last questions. There are some more questions that are coming below there. Okay, so we'll get started from question 1. Now the question says express each of the following angles in degrees. So here the measure we've been given are radians. Now you want us to convert to degrees. For the second question, it's actually the opposite. They've given us the angles in radians, or sorry, in degrees, and then they want us to deal with what do I say again, in radians. So we've been given radians, they want us to take 2 degrees in the first question, and then the second question they've given us degrees, they want us to take them to radians. Okay, how do we handle these simple questions? So for the first one, there are 2 ways. 3 pi over 4. So one thing that you can understand is the fact that if I was to give you the quadrants and then I give you to say that's 0, that's 90, this is 180. You should also understand that where there's 180, it's pi. Where there's 90, it's pi over 2, meaning that it's half of pi. So this very part is what we're going to be using as our conversion factor. So if you're going to be given 3 pi over 4, there are 2 ways you can handle it. Either by multiplying by 180 over pi. So you're putting pi on the opposite what? You're putting it on the denominator so that it can divide. Okay? So therefore the pi will divide, and then you end up with just 3 multiplied by 180 over 4. Okay? At this point you can easily divide, right? 4 into 180, that should be giving us 45. So 4 into 18 is how many times? That's 4 into 16, carry 2, that's 5, 45. 45 times 3. So 45 by 3 is what? So that's a 15, that's a 12, 13, so 135. So basically that's 135 degrees. Okay. So another faster way of, instead of doing whatever we did here, would be where there's pi, just put 180. So 3 times 180 over 4. We find that we're getting to the same answer, right? Now conversion back is actually the opposite. So let's work with the same 135 that I've found. 135 degrees. Or even before we get to that, let me give you another example. Let's say we've got pi over 9. So there are two ways of converting this. One would be, since pi is on top, we'll put it on the denominator on the what we're multiplying with, and then we'll put 180 on top. So you end up with just 180 remaining, divided by 9. 9 into 18 is twice, so remaining with a 20 on top. Or just instead put 180 where there's a pi. Yeah, end up with the same result. You can go to 11 pi. Feel free to pause the video and try out this one, convert it to degrees. So basically that gives us 11 pi over 18 multiplied by, so a pi will be on the bottom and then 180 on top. So pi 18 here it's 1, 18 there it's 1, so we have 11 multiplied by 10, which is just going to be 110 degrees. Okay, 155, which we found there, should be able to give us back that. So since here we've got degrees, when multiplying we're going to put the degrees on the bottom, which is 180, and then on top we'll put the pi. Okay, find common factors between 135 and 180. Okay, so we find that 45 can be divided. 45 into 155 is 3 times, and then into 180. If you look at the quadrants, this can be divided into 45, 45, 45, 4 times. So remaining with 3 pi on top over 4. That's how you get to radians. Okay, now let's do a bit of some practice. 210 degrees. How do you convert that to radians? Pause the video and try it out. So obviously we'll divide by degrees and then multiply by the pi. So any common factors you can think of? In case you can't think of big values, let's think of 10. 10 into 210 is 21. That's 18. 18 and 21 should have a common factor of what? 18 can be divided by 9. 18 can be divided by 3. 21 can be divided by 3 as well. 3 into 18 is 6. 3 into 21 is how many times? 7. So we have 7 pi on top over 6 radians. Okay, for practice, let's convert theta as well. Pause the video and try it out. So divide by 180, and then multiply by the pi. Now we know 30 or 3 can cancel the zeros. Now 3 there it's 1. 3 into 18 is 6. Right? So we have pi over 6. That's it for question 1 and 2, right? You're able to deal with the others. This is very simple and straightforward. Now, question 3 is asking us to express the given angles in terms of acute angles. So we have to understand, because we can see actually question 4 is having the word acute angle. So from my understanding, from what I know so far, an acute angle is an angle that is between 0 and 90, or in other terms, yeah, between this range, the first quadrant to be specific, that's acute. Was acute angles. So whenever they're asking you for that, all that they're just trying to do is asking you to find the angles in the first quadrant. Now there are a few things that you have to know that I have already taught in the basics to trigonometry. So ensure you're registered on our site. I've explained all the basics of what I'm talking about right now. Okay, so all students take calculus. So for those who want to watch the introduction lesson and the full topic on our website, the link is given in the description. Okay, So students take calculus. So you have to know where each is positive. In the first quadrant, all are positive. In the second, only the sine, tan in the third, and cosine in the fourth quadrant. I know that, please. So when they give you sine 170, every time ensure that you're dealing with the x-axis. This side we've got 180. This side you have 0. Okay, and there we've got 90. So actually where there is 0, if you after a full evolution, it becomes 360 degrees. So 170, where do you expect to find 170? 170 is less than 180, right? But in the second quadrant. So 170. Now what's the difference between the 180 and the 170? There's a difference of what? A 10. So that 10 gives you the angle in the what? In the first quadrant. So in other terms, what we're trying to say here is sine 170, which is given in the question, is basically just equal to sine 10 degrees in the first quadrant. Now what determines the sign of this is where you are. We are in the second quadrant. Sine is what? Positive, so it remains positive. You can get a calculator, you will see that basically sine 170 is equal to sine 10. Okay, so if you've got an angle that is less than 180, or in the second quadrant, for you to find the reference angle, subtract from 180. If it's after 180, like maybe say 210, but less than 270, you should ensure that you do what? That you subtract 180 from it. If we had a 210, for example, 210 minus 180 would be a 30. So that would be the reference angle 30. Yeah. So it will make sense later on as we get down there. Let's look at the next one, tan 330 or tan 300. So where is 300? Do you think it's in the fourth third or the fourth quadrant? So 300 clearly is after 270, so it's going to be in the fourth quadrant. So when you've got an angle in the fourth quadrant, you subtract from 360. 360 minus the 300, it gives us tan what? 60. Now, what determines the sign is where you are. This quadrant only cosine is positive, so it's going to be negative tan 60. Okay, implying that tan 300 is going to give you a negative answer, negative tan of 60. Okay, that's very, very important. Now pause the video and try out the next one, cos 200. When you say cos 200, what do you basically mean? Which quadrant are you in to start with? 200 is between 180 and 270, so meaning that we are in the third quadrant. So subtract 180 from it. 200 minus 180 is what? It's 20. So cos 20 degrees. By the way, when you subtract by either 180 or 360, or from 360 and from 180, always, if you've done the right thing, you should get an answer which is less than 90. If you get an answer which is over 90, then it is not an acute angle, then you're wrong. Okay, so know that. So cos 200 is equal to cos 20 degrees, because we found the difference between 180 and 200, because 200 is in the third quadrant. Now what determines the sign is where we are. We are in the third quadrant. Tan is positive, so all the other two are negative, so therefore it's negative cosine of 20 degrees. Okay, now we've been given some examples of negative angles. Now we understand that angles basically from the quadrants, angles are move anti-clockwise. So if we're going to move clockwise direction, in a clockwise way like this, it means it's going to be negative. So if you say you're given negative 50 degrees, that's the same as, instead of going this way, the normal way, but you go the clockwise way. By how much? 50. Now 50 will not make us go beyond, will not make us go up to 270. It's just within the fourth quadrant, right? 50. So 50, negative 50 means you go down in the fourth quadrant instead of going up as we do every time. So that's why some people at this point will just say, whenever you've got a negative, add to 360 to know where you are going to be. So 360 plus the negative 50, that will probably give you a value of 3 what? 310. So that's the angle we're dealing with. So if you look at sine negative 50, that's the same as sine 310 in a clockwise way. Or in the anti-clockwise way, yeah. But for me, I would look at it in this point of view, knowing that 50 degrees means we've gone down by 50. So this 50 is within the fourth quadrant. So we're supposed to subtract from 360 again, which will still give us 310. Now 310, what angle do we have? We've got sine there, so sine 310. Now is sine positive or negative in the fourth quadrant? It's of course negative because only cosine is positive there. Or students take calculus. Cosine is positive, so sine should be negative. Okay, now don't forget that we need to find the acute what? Angle. So the angle we are making with the x-axis is 50. So if we go back in the first quadrant as well, it's going to be 50. Okay. In other terms, if you want, since you've got a 310, find the difference between 310 and 360, which is still going to give you what? A 50. So it's going to be negative because sine is actually negative in the fourth quadrant. That's very important and key to understand. So with what I've explained, are you willing to try out cos of negative 20, cosine negative 20? Okay, pause if you don't try it out. So that just means we are going again 20 degrees in the other direction. So since it's 20 degrees below that and it's an acute angle itself, you can just bring it up on top. So cos negative 20 is the same as cosine 20. Now is it positive or negative? Since it's in the fourth quadrant, cosine is positive in the fourth quadrant. All students take calculus. Cosine is positive, so that's positive. You can try on the calculator. Cosine negative 20. Let me grab my calculator here. Cosine of negative 20 is 0.9396. Even positive, same answer. Okay. Now the next one is a bit unique and a bit different from the third one, as you would see. Here we are taught to look at sine 100, cos 330. Now here they're asking to say express in terms of trigonometric ratios of acute angles. So not only are we finding acute angles, but we're going a step further and find the ratios or the actual values. Okay. Now this is a part that requires you to understand the aspect of the spatial angles. Okay. By now, if you've not yet gone to the introductory video to trigonometry where I've explained the 30-60 triangle, okay, so watch that video. 30-60, 45-45, these are going to be very cardinal as we look at these questions. So I'll just give you one. I'll give you this one only. 30-60. So SOHCAHTOA tells us we know sine 30 is equal to 1 over 2, meaning that that is opposite over hypotenuse according to SOHCAHTOA. So the hypotenuse is 2, the opposite is 1. The other side will obviously be root of 3. We can generate the other angles from this triangle that involve 30 and 60, and even including 90, by the way. Okay. So sine 100. So the first step is to find the the acute angle. Now, sine 100. Always you're advised to draw the quadrant. All students take calculus. And then, if you look at that, what are we saying? Where is 100? Remember it is 0, 90, 180 or pi, and then this is 270, 360. So when you're talking about 100, where is it? Is it in the first, second? So we can say that it's in the second quadrant because it's between 90 and what? 180. So when you've got an angle in the second quadrant, to find the reference angle or the acute angle, subtract from 180. So it's going to be sine 180 minus 100. So 180 minus 100 is what? That's 80. Now, in the second quadrant, only sine is positive, so this is still positive because we have sine there in the second quadrant. Now, is there a way that you can express sine 180 in terms of addition of either 30, 45, 60, 90, or any special angles that you can think of? I couldn't think of any, so I'll just end at this point for this question, unfortunately. If you can think of a way, please comment give us a comment and we'll gradually review that. Okay, now let's look at this one. Cos 330. 330 is in which quadrant? It's between 270 and 360. So that makes it, for us to find the acute angle, subtract from 360. So cos 330 gives us what? Cos 360 minus 330. That's cos theta. Now cosine is positive in the fourth quadrant, so it will remain positive. Now cosine 30, we can, using the triangle that I've drawn on the left, we can find the ratio there. According to SOHCAHTOA, for the cosine part, it basically cosine is equal to the adjacent side to the angle 30, which is root 3, over the hypotenuse, which is a 2. So that is the ratio, positive root 3 over 2. If the acute angle was negative cosine 30, the answer was also going to be negative root 3 over 2. Now tan 500. Now whenever you see an angle that is beyond 360, just quickly, don't even waste your time, subtract 360 to understand which quadrant you're in. So 500 minus 360 is what? So to 360 we just need to add a 40 to make it 400, and then from 400 to a 500 is 100, so it's 140. So forget about the 500, we're not interested in it. What that means is we just did one full revolution and then added an extra 140, so we end up falling in the second quadrant. Okay, so tan 140, since it's in the second quadrant, the 140 can be subtracted from 180. It gives us what? 40. Is tan negative or positive in the second quadrant? Only sine is positive, so this is going to be negative tan 40. Is there a way we can find tan 40 by either expressing it in terms of addition, subtraction, or 30, 45, 60? I can't think of any way right now. So we'll just end at that point. Now we can deal with some radians. We've dealt with the degrees for too long. Let's get to work with the radians. So I can just change a few things here. So that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Some of you are so conversant with degrees that you don't want to work with radians. So if you want, since I've already taught you the conversions, and maybe you already know, work with that. Convert your angles, the given angles, to degrees before you deal with them in radians. So if you look at the first one, sine 2 pi over 3, just for practice sake, what do you think would be that angle in degrees? So a good student will just put 180 where is pi, and then divide by 3, which is of course going to be 60 times 2, 120. So what are you trying to find is sine 120. Okay, so sine 120 is in which quadrant? It's in the second quadrant. So that is in the second quadrant. 2 pi over 3, or 2 third is less than a pi, so we can subtract from pi. Okay, common denominator 3, 1 through 3, it's 3 times pi, 3 pi minus 2 pi, which is going to give us pi over 3. So we have sine equal to sine 2 pi over 3 is equal to sine, we found pi over 3. Okay, now is sine positive or negative in the second quadrant? It's positive, so that remains positive. Now sine pi over 3, some of you know that you put 180 where there is a pi. 180 divided by 3 is what? 60. So what we're trying to find there is sine 60. This applies. So sine 60 is obviously going to be opposite root 3 over hypotenuse 2. Pause the video and try out now. Combine the aspects of radians with negatives, right? What do we have for the negatives? Cosine negative pi over 6. Not conversant with degrees. Right? So work with a 2 pi there. 2 pi. And then we are going to subtract, since we're going below by that magnitude, negative 5 pi over 6. The fact that negative 5 over 6 or 5 over 6 is less than a 1. Okay? Now if you want to try this, if you want to know where we're going, and you're not so confident with radians, so just convert it to degrees quickly. Negative 5, where there's pi, we'll put 180 over 6. 6 there, it's 1, 6 there, it's into 18, it's like 3, so 30. 30 times 5 is like 150. So I have cosine of negative 150. So you can clearly see now that it gives you a clear picture when you convert to degrees. If you are confident with degrees, you would understand now that this is going to go beyond the 3 pi over 2. It's going to be 150 is going to be somewhere here, because from this is 90, so the 90 plus, for us to end up with what, a 150, would have to add what to, would have to add a 60, so it's an extra 60, okay, from the 3 pi over 2. Now the angle that we're interested in for us is this angle. And how do we find it? Since we've already moved by 60 within the third quadrant, this is 60, because here it's 90. 90 from 360, from 2 pi to 3 pi over 2 is a 90. and then in 90 we've added a 60 to make it 150, and it's negative because we are moving in the clockwise direction. So that means we're remaining with only an extra 30. Okay, it means we're remaining with a 30 between the 180 and our angle. So what becomes the reference angle? Remember, every time you're trying to deal with angles, the angles that you're interested in are the angles between the angle and 180, or after 180, and less than 360. These are the angles that are of our interest. So we can't get 60, which is made between the 270 and the angle. We are interested in finding the difference between the angle and pi. So we are saying that the difference is 30. Okay. Now 30, you know that if you convert it to radians, it's going to be pi over 6, right? Now you ask yourself a question. So that's going to be cos pi over 6. Is cosine positive or negative in the quadrant we are in? This angle fell in this quadrant where tan is positive, so it's going to be negative. Now cosine 30, looking at this triangle, tells us adjacent, so it will be negative root 3 over hypotenuse 2. Okay, so this is how you handle question 3 and 4 basically. Now question 5, I'm not going to answer question 5 just now. I'm just going to give you a hint now to go about question 5 and 6. Given that theta is an acute angle, express it in terms of sine. So we're basically just doing whatever we've done so far. Okay? So when you see sine negative pi, now one of the key statements that you're given here is where I thought that the angle should be acute. The theta in the brackets is acute, meaning that it's less than 90. So if I give you negative theta and it's an acute angle, first of all, I said if it's negative, you have to understand that then you're going below the below instead of going up. So that will be the angle that you make here. Now the fact that the angle is acute, it means it doesn't go beyond 270 because it's less than 90. And so since it's less than 90 and is within the fourth quadrant, and this is the angle it is making with the 360, that angle itself automatically becomes what? The reference angle in the first quadrant. So that becomes sine theta. Now the question is sine positive or negative in the fourth quadrant? Since this angle is in the fourth quadrant, sine is negative because only cosine is positive in the fourth quadrant. That concept applies to all the other questions, and you can actually prove this. Sine negative 30 is equal to negative sine 30. You can punch these on the calculator. They're going to give you same answer, negative 0.5. Okay. Now, to make it more interesting, let me try to attempt part 2 of question 5 so that you have your homework to try out the all of question 5 and 6 in both radians and angles, or and degrees, sorry, where necessary. So here we have sine pi over plus theta. So I told you this is 0, that is pi over 2, and then this is pi, right? Because this is 3 pi over 2. When they tell you to say you've got pi plus theta, it implies, since the theta is an acute angle, that's a difference now. That's an angle it is making with the pi or the 180. So what quadrant? That angle is in which quadrant? It's in the third quadrant. Now we understand that only tan is positive in the third quadrant. Remember, all students take calculus, right? So the sine pi plus theta, in the first quadrant the reference angle can just be the same angle theta. So the pi that is put there is just helping us determine the quadrant that we are in, and that is the third quadrant, so that will make the answer to be negative. Okay, so it's negative sine of theta. So you can now understand 360 minus pi, it means the angle is in this quadrant. It is a few degrees less than 360. So that angle is the theta. Now that would be sine what? Sine theta. Is it positive or negative in this quadrant? It's negative. Apply the concepts to answer the others, and also question 6. This is where I'll end in this video. Okay, now if you want to have access to all these other questions that are ahead, register on our site or Patreon or YouTube Premium. You'll be able to access all these solutions. Okay, these are a lot of questions that can help you understand trig, and this will help you out. We'll continue from question 5. Given that theta is an acute angle, express the following in terms of sine theta. Alright, so how do we handle that question? So what they expect us to do is just end up with a positive theta there. We don't want us to have negative theta or any additions like we can see here. So basically, when you try to analyze this question, it's based on the idea of reference angles. If you know what reference angles mean, So when you look at the 4 quadrants, I like giving an example of the angle theta. So if you've got an angle theta in the first quadrant, to find angles in the other quadrants, in the second and the third, for the second, you subtract from 180, so it's going to be the 30 there as a difference, and then in the third it's 30 after 180, and then in the fourth quadrant it's 360 minus 30. So this is what we are seeing here. For you to find an angle that is 30 after 80 is you add, there you subtract, here you subtract from 360, the 30. So the angles you're going to find are going to be differences of what? Of the 30. Okay, so here it will be 150, there it's going to be 210, there's going to be 330. And for sure, sine, if you look at sine 30 is the same as sine 150. Okay, same in magnitude to sine 210, and same in magnitude to sine 330, except the signs will be different in that sine is negative in the third and in the fourth quadrant. Remember, I've told you all students take calculus. So sine is positive in the second quadrant, tan in the third, cos in the fourth. They are all positive in the first quadrant. So that's what referencing angles mean. Okay, now using that idea, let's not forget one important key in the question. We are told theta is an acute angle. An acute angle is an angle that is from 0, okay, and then it should be less than 90. That's an acute angle. So if an angle is an acute, it implies it can go beyond a quadrant. Okay, you understand what I mean by that. I'll bring you back to this. Now let's answer the questions. Now when you look at sine negative theta, what that implies is whenever you see a negative, it implies instead of moving the normal way that we move the anti-clockwise way of measuring angles, for negative you can go the clockwise way. So negative theta is that angle there below that. Okay, so it's negative. Now why am I ending within the fourth quadrant? The reason is simple, because it's an acute angle, so it can't go beyond the 90, so it's within the fourth quadrant. And so it's very easy to find the reference angle in the first quadrant. Okay, it's going to be of the same magnitude theta. Okay, sine what? Theta. Now this angle is in the fourth quadrant. Now ask yourself a question: is sine positive in the fourth quadrant? No, we said all students take calculus. So cosine is the one that is positive in the fourth quadrant. So the answer therefore is negative sine of theta. Okay, That's it for the first one. Now the next ones are actually more easier. In fact, they are all just the same. So we understand this is 0. That is pi over 2 or 90 if you want. This is pi or 180 if you like, and then that's like 3 pi over 2. And then where there's 0 again, that's where 360 is, or 2 pi in radians. Okay, so find sine that. So the fact that theta is actually an acute angle, implying that it's between 0 and 90, tells us, if it tells you sine pi plus theta, it tells you, or you're able to predict to say that angle is E. Okay, so that angle is this pi plus theta. So meaning that that angle is occurring in which quadrant? It's in the third quadrant. So the reference angle is right away to remain theta itself. So sine pi plus theta is equal to sine theta. Now the question is sine positive or negative in this quadrant? So negative. All students take calculus. Tan is one that's positive in the third quadrant, so this is negative sign. Can move to the next one. Now for the next one, what we have is an angle 360 minus theta. So that angle is going to be A, 360 less by theta, right? So if I move 2 pi, I can put 360 to show that's where 360 is. So 360 minus pi is this angle A. So a reference angle would be pi in the first quadrant, and then is it positive or negative in that quadrant? Is sine positive or negative? It is negative. So sine 360 minus theta is the same as negative sine of theta. Now things are getting more interesting here. We're now going to the negative ones. How do we handle the negative ones? Sine negative of 180 degrees plus theta. So we can simplify that, distribute the negative if you like. Then you're going to have negative 180 degrees minus theta. That's just one way that you can handle it. Or you can handle it the way it was given to us, by understanding that the fact that there's a negative, it implies we're going the clockwise way. So first of all, how do you move the 180? You've moved the 180 in the negative way, and then in addition to that, you've got that theta. So it's going to be like that. Now in which quadrant is that? That is the second quadrant. So we can find the reference angle by just getting that theta. So this is the same as sine theta. Now is it positive or negative in this quadrant? Sine is positive in the second quadrant, so this remains positive sine of theta. If you're not confident with just going direct, understanding that, you can actually distribute the negative, move negative 180, which means you move clockwise again in the same manner, and then minus, which also indicate you're still moving the clockwise way. Yeah, you end up with the same answer in the second quadrant. So we've seen how we can express these angles in terms of sine theta by understanding the quadrants. Okay, the same principle can be applied to question 6. So pause the video and try out these ones as well. Okay, I'm hoping you did pause the video, and so now let me show you. Let's see you verify your answers. It's okay to get some wrong. It indicates where you need to, what you need to work on. So equally here we are told theta is an acute angle. We are supposed to express what we are given in terms of either cosine or tan. So for the first one, obviously that's cosine. Now you need to improve your ability of identifying the quadrants that you're dealing with. Okay, so they've given us pi minus theta, so that is an angle in the second quadrant because it's theta less than 180. Okay, so this is the angle that they're talking about. Remember, theta is what? An acute angle. So that same angle comes back to the first quadrant, so that's going to be cosine of theta. Now, is it negative or positive? So we said sine is positive in the second quadrant, so therefore cosine is negative. Don't forget our slogan: all students take calculus. Simple. The next one, 180 plus theta. 180, you know where there's the pi, that's also where 180 is. They are equal. So plus, it means it's coming after. So that's where it is. So I can take back that again also to the first quadrant. So that will be cosine. Now here tan is positive, so cosine is negative. So it still remains negative cosine of the angle theta. Okay, pause the video and try out the tangent ones. The next one is tan 180 degrees plus. So it's coming after 180. So that means it's in the third quadrant because the angle theta is acute, so it can't go beyond 270. So it's going to be within this quadrant, 180 plus that theta. So equally, if you take it back, it will still be theta in the first quadrant. So that's tan theta. Now this will remain positive because tan is actually positive in the third quadrant. Then this one, quite interesting. Pause the video and try it out. Have you paused the video or you're still watching? Pi 0, negative pi. So negative pi already, that indicates clockwise way of moving. Now it's a bit crazy here because theta is not matching with the sign of the other side. So the fact that it's positive, it entails we're supposed now to get back this direction by magnitude of theta. So that same angle applied to the first quadrant. So we are in the third quadrant. So that is equal to tan theta. It will remain positive because we are within the third quadrant because of how we've moved. Well, if it was positive, we would have moved in a different way. It was going to be again in the third quadrant, but would have moved this way. Yeah. So that's how we handle question 5 and 6. Question 7 is quite straightforward. Here we are supposed to first of all find, of course, the reference angles in the first quadrant and then find the actual ratios, trigonometric ratios, so that we find the exact values. Sine 135. Where is sine 135? So 135 should be between 90 and 180. So you can draw a line somewhere there and then call that 135. How do you find the reference angle? So we'll draw a line there. 180 minus 35 is what? That should be 45 degrees. So that difference is what we're going to take to our first quadrant. So sine 135 therefore is equal to sine 45. Is sine positive or negative in the second quadrant? It's positive, so this remains positive. Now sine 45, you and I have already been introduced to a 45-45 triangle, right? I hope you are by now. So if you're not, please watch our video on introduction to trigonometry. I explained all these special angles. So that's 45, 45. The sides are 1, 1, and root of 2. Now by SOHCAHTOA, we know that sine is opposite over hypotenuse. Opposite of 45 in that triangle is 1. The hypotenuse is root of 2. So that is positive 1 over root of 2 for the first one. Now the second one, that's negative 60. Negative 60, where do we find negative 60? So we go this way. So it will be within the fourth quadrant. We've moved the clockwise way 60 degrees. So that same angle, since it's already less than 90, since it's already an acute angle, it remains the same angle in the first quadrant. No need of any subtractions. So sine negative 60 is the same as sine 60. Now the sine. What is positive in the fourth quadrant? All students take calculus. Cosine is positive, so sine is negative. So negative sine 60. Now if you go to a 30-60 triangle, I'll show you again just to remind you of what you're supposed to know by heart. So sine 30, if we put our 30 there, 1, 2, 3, this missing side is 60. So if you say sine is 60, what's the opposite of that? So it's negative root 3 over 2. According to SOHCAHTOA, sine is equal to theta. Sine theta is equal to opposite over hypotenuse. So the opposite of 60 is root 3. The hypotenuse of that triangle is 2. It's negative because the negative 60 angle is ending up in the fourth quadrant where sine is a negative. Now 11 pi over 6. I know most of us who may not be so confident with radians, for you to understand that, if you add the calculator, you'd actually divide so that you see. But from what I'm seeing, 11 over 6, that's 1 over. So I believe that should be an angle that is after 180 or after pi. So it may be in the third or the fourth quadrant. So let's just convert it to degrees by placing 180 where there is pi. So we have 11 pi. So where is pi, I put 180 over 6. 6 into 18 is 3. So that gives us a 30. 30 times 11. That's 30, 0, 3, 330. So the angle itself is 330. 330 is somewhere there. Now sine 330, it's in the fourth quadrant. So for us to find the reference angle, we're supposed to subtract from 360. And if we do, we're going to get a 30. So the sine of that is equal to sine 30. Now, is sine positive or negative in the fourth quadrant? Negative. So therefore, the answer becomes sine 30. We know it's half. So negative half is the answer. From this very triangle, we can get the fact that sine 30 is 1 over 2 or 0.5. The next one is cos 120. This is 180. So 120 is somewhere here. The difference between 120 and 180 is 60. So 60 becomes the reference angle in the first quadrant. So cos 120 is equal to cos 60. Now is cosine positive or negative in the second quadrant? It's negative. So negative cos 60 is what? Cos 60 is half, so negative 1 over 2 or negative 0.5. That cos 60 can also be gotten from this triangle. Cosine is adjacent over hypotenuse from SOHCAHTOA. Pause the video and try out the last two. Five pi over 3. So 180 over pi. 3 there. There it's 60. 5 times 60 is 300. Cos 300. Do a mental exercise without drawing anything. Would you try that? What do you think is the answer? Well, this 300 is probably in the fourth quadrant. We can subtract from the 360. We get cos 60 as a difference. And then, is cosine positive or negative in the fourth quadrant? It's positive. All students, they calculate so positive. Cosine 60, I'm from showing you the triangle. That's what? Positive half. Okay. Then the last one, tan 135. Tan 155 is between what? 90 and 180. So that's the second quadrant. Subtract from 180. You get the difference over 45. Is tan positive or negative in the second quadrant? It's negative. Because sine is one that is positive. Yeah. So I already said tan 45. In fact, I said sine 45 is 1 over root of 2. Now from that triangle that I drew, because 45, 45, both sine and cosine are the same. So we know an identity tan is sine divided by cosine. So this is a 1. Even if you go to the triangle, okay? So that's how you're supposed to handle that. We are done with question 7. Negative 1 is the answer to the last one. Now let's look at question 8. Alright, so look at question 8. Here we're told to find, without using a calculator, the values of sine theta and cosine of theta. So given that tan theta is equal to 5 over 12 for the first one, okay, tan of theta is 5 over 12, and given that the angle theta is acute, meaning that it's between 0 and 90. Okay, so we'll actually just draw. Let me just draw a triangle. So from SOHCAHTOA, try to fill the values on the triangle. Which one is the opposite, which one is the adjacent? So the TOA part, tan of theta is equal to opposite over adjacent. Now in this case we are told tan theta is 5 over 12. So therefore the opposite side to, if we say that is our theta, the opposite becomes 5, the adjacent is 12. So we can try to find the missing side. Since this is a right angle triangle, we can use Pythagoras theorem. The hypotenuse, let's call it x in this case. The square of the hypotenuse is equal to the square of the other two sides. So that's going to be 12 squared plus 5 squared. So we have x squared is equal to 144 plus 25. That should be 169. Now what is the square root of 169? That should be 13. So that is our hypotenuse, 13. Now with that, we're able to find the other missing values. Sine of theta. Now from SOHCAHTOA, we know that sine theta is equal to opposite over what? Hypotenuse. Same with SOHCAHTOA. It's telling us all that. Sine is opposite over the hypotenuse. The opposite to the angle theta is 5. Hypotenuse is 12. Sorry, 13. And then cos of theta, the adjacent to angle theta, or angle theta, is 12. The hypotenuse is 13. So we've answered the first part of the question. Let's go to the second part. Pause the video and try that out. Now that we are told the angle is obtuse. The angle is obtuse. So by the way, some of you may be asking, why is the importance of knowing what angle we're dealing with? Because we didn't see any value of acute helping us, right? Well, it did. It told us we're only going to consider the positive side, so we could have drawn it like that, okay, and put the angle theta there, so that the opposite is one that was like 5, this 12, and that 13. Now the next one, we are told the angle is obtuse. So obtuse angles are angles that exist in the second quadrant, but they are between 90 and 180. Of course, the last two quadrants, those are reflex angles. So obtuse, this is what we expect for an obtuse angle, right? So we can call this part theta. So the x value is of course going to be negative. So now look at what we're given here. We're told, given that cosine is negative 3 over 5. So feel free to pause the video and try out that. Cosine of theta is equal to negative 3 over 5. So obviously, from SOHCAHTOA, we know that that's cosine theta is equal to adjacent over what? Hypotenuse. Even from the triangle, we know this is where the 3 is going to be, and then the 5 is going to be the what? The hypotenuse, since it's SOHCAHTOA. Now we can find that we can find the opposite. So this is the longest side. 5 squared should be equal to 3 squared plus the missing side, let's call it y. 25, the 3 squared goes the other side, becomes minus 9. That's 16. Root of 16 is 4. The positive value, we'll get the positive value alone. So we can easily find the other the missing ones now. Sine of theta is going to be opposite over the hypotenuse, so opposite is 4 over 5, and then tan is opposite over adjacent. We're good. Then for the last one, we're told 3 pi over 2. That means that angle is between 270 and 360. It's in the fourth quadrant. So angle theta So by the way, there's no issue. You can actually draw this triangle even without this if you want. So negative 7 over 25. That's sine. So sine is given as opposite over hypotenuse from SOHCAHTOA. The opposite 7, hypotenuse 25. We don't know which one is negative. Opposite to the angle theta, in this case 7. So that's where the negative would be coming from, and then the hypotenuse is 25. So we can find the missing side. 25 squared minus 7 squared should be equal to the missing side. Let's call it C. Now 25 by 25 should be something that we should be able to multiply. I know most of you are saying okay, that may not be allowed. So 25 by 25, that's a 25, 5 times 2, 10, 12, 10, 5. So 525. 7 times 7 is 49. You can easily subtract 525 minus 49, 476. So a square root of that. Now the question is that a perfect square? No, it's not. So since in this case, say we are taught calculator is not allowed, we can just put it as it is. The root of 476. Okay? And you can find the missing ones. Cosine of theta is adjacent over hypotenuse. The adjacent to the angle theta is the root of 476 divided by the square root sorry, not the hypotenuse, which is 25, and then tan of theta is opposite to the angle, which is 7, and then 25, right? Now, one principle that I've been forgetting in the previous questions is appreciating the quadrant where you are. The fact that this angle is in the fourth quadrant, remember our 7 here should be negative, so even the answer there should just be negative 7. Or even just by knowing that the fact that the angle theta is in the fourth quadrant, only cosine is positive in this quadrant, so therefore the answer should be negative for tan. So if I take you back to previous answers we had, you should put that into consideration. If I take you back to previous one, well, cosine will still remain positive by the way, because cosine is positive in the fourth quadrant. Now if I take it to the previous one, our angle was obtuse. Okay. 3, 5. So this is a bit negative 3. And then we found the 4 there. So what are we finding? Tan. Tan should be negative. Opposite to the angle theta was 4. So negative 4 over 3 should be the answer. And then for sine, should be positive. Opposite over hypotenuse. 4 over 5. Yeah, that's good. Now for the first one, all are to be positive because we are dealing with the first quadrant. The theta is acute. I just needed to mention that. I think that's very, very important when it comes to such questions. Now we're on question 9. Question 9, we are told find the values of theta from pi to 2 pi inclusive, which satisfy the following equations, right? How do we handle such questions? What do we do? Is a question. Okay. So look at that. Cosine of theta is equal to 1 over 4. So if you're not yet introduced to the inverses of trig, this is where they come in. They are cosine or cosine inverse. So the inverse of cosine is cosine inverse or cosine. So we'll use that to find the answer, the first answer. Okay. Now I don't think 1 over 4 would give us any special angle. So I'll just end up giving you the answer. Cosine inverse of 1 over 4 on my calculator is something like 75.5. Okay. Now to find the other answer, ask yourself in which quadrant is cosine positive. It's in the last quadrant. All students take calculus. Cosine is positive in the fourth quadrant. To find an angle in the fourth quadrant, subtract from 360. So the other possible answer would be 360 minus cosine inverse of 1 over 4. Now I want to ensure that you're dealing with radians, so you may change your calculator to radians if you want. Pressing shift, mod, not necessarily shift, just press mod and then mod again, and then option 2 as radians. So cosine inverse of 1 over 4, instead of 75 we can put 1.32, and then instead of 360 we can put another possible solution to be 2 pi. So you can leave this as it is if calculators are not given to you, since you can't find the angle. can leave it like that. And then the other possible solution is going to be in the fourth quadrant, because that's where our cosine is positive. Now this very question, how would you handle it if we add negative 1 over 4? So in that case, for first of all, you'd ignore the negative. If we add cosine pi of negative 1 over 4, first of all, ignore the negative and find the answers we have. We can find it in terms of alpha, so that would be again cosine inverse of, that's the one that can give us a positive result. Now we are not interested in that one. So therefore, in which quadrants do we expect cosine to be negative? Remember, all students take calculus. So in the second and in the third. So the possible theta values would be, in the second it's going to be pi minus your answer for a positive, and then also pi plus. Okay, that's how you handle that without a calculator. So I've shown you both cases. Now they want you to find answers specifically between theta to 2 pi. So if I bring you back, it means this one doesn't qualify to be an answer for the first one due to the range. So the possible answer for the first one will only be this. And then for the, if we are to consider the negative ones, the only answer that is between pi and 2 pi is this one. But where it is open to say from either 0 degrees to 360 degrees, or from 0 to 2 pi, all of these would qualify. So you end up with 4 solutions if we add both the negative and the positive, and that would usually occur in the case that is in question 10. Tan theta is equal to 1. Theta is tan inverse of 1. I think we're from looking at the 45 triangle. This is the only triangle that gave us tan to be 1 somewhere, right? Look at where I'm putting the angles. So one's root of 2. So tan in that case, the opposite and the adjacent are the same, so it's 1. So theta becomes, if it was in degrees, it would be 45 degrees. Now I want to do with radians. 45 into radians is what? So multiply by pi of 180. There it's 1 into 180, 45 times 2 is 90, so it's going to be 4 times in 180. So that's pi over 4. It would qualify if we're dealing between 0 and 2 pi, but we're interested only in the angles from pi to 2 pi. So where is tan positive? In the third quadrant. So we can find this angle there. How? It's coming after theta. So a possible result is therefore theta plus pi over 4, which you can easily add, which will give you 5 pi over 4 after performing basic additions or fractions. So be at liberty of pausing the video and trying out the remaining ones. Cosecant of theta is equal to 2. Cosecant is an identity which implies 1 over sine of theta. So if we multiply both sides by sine theta, we end up with 2 sine of theta. Divide both sides by 2, we end up with 1 over 2 is equal to sine of theta. So sine of theta is equal to 1 over 2. So therefore, we are interested in finding the angle theta. Theta is going to be the sine inverse of half. Now what is a 30, right? What angle of theta can give us half? It's 30 in degrees. Now we know what is pi over 6. Okay, in radians. So we're not interested in finding that value, we're interested in finding the values between pi and 2 pi. So is it possible to find the value of sine which is between theta and 2 pi, which is positive? I don't think so. So sine is only positive between 0 and pi. Between pi and 2 pi, sine has got negative values, so there is no satisfying solution to the third one there. Then we have sine of theta minus pi over 6 is equal to negative 3 over 2. Our goal is to find the value of theta. So find both sides the sine inverse. So theta minus pi over 6 remains this side. This side we're going to have sine inverse of negative 3 over 2. Now I don't want to solve this the way it is. We ignore the negative for once and find alpha. Now we know that if we are to look at the 30-60 triangle, what value of sine gives us 3 over 2 sine 60? So sine 60 is a possible result in degrees. To find another angle which would give us a positive result, well, actually we're not interested in the positive result, so that's just 60. 60 would give us root 3 over 2. Now we're not interested in the 60, we're interested in the values that can give us a what? A negative. In which quadrants is sine negative? It's in the third and the fourth. All students take calculus. So where tangent and cosine are positive, that's where sine is negative. So to find the angles in the third and the fourth quadrant, we'll first of all add to pi. Now this 60, by now you should know it is the same as pi over 3. You should be able to convert to radians without struggles, right? Now the two answers therefore that we're going to have would be, in the third quadrant, it's going to come after pi, so it's going to be pi plus pi over 3 for our theta. That will give us a negative result. And then the other one would be theta is equal to 2 pi minus pi over 3, which can be simplified, right? So I can actually write down these values. 3 times the pi there, that gives us 3 pi plus pi, 4 pi over 3. And then 3 times the 2 pi, that's a 6 pi minus a pi, 5 pi over 3. So I've come up with two equations so far. Theta is equal to pi over 6. This one has gone the other side. Now the first result would be adding to 4 pi over 3, and then the other one to 5 pi over 3. Yeah, at this point you can now come out, you know you've got a common denominator there. So yeah, it's 6. So I have pi plus 8 pi 9 pi over 6, 3 pi over 2. This side 6, pi, 10, 11. These are the two possible answers. Now the question is, are they between 2 pi and pi? 3 pi over 2 of course is, so is that. Okay, we're good. That was question 9.